Okay, so hello everyone, welcome. Can you hear me?
Yes, sir.
Okay, thank you. Just waiting 1 minute, then we'll start. Okay, so we will start this session. So basically, today is our second day, and I hope all of you already got the recorded video class and also practice code. Okay, and after completing the 3 hours live training, then we talk about the 1 hours for your problem solving regarding the previous class. Okay, if you have any confusion about the assignment or if you have any confusion about the any topic, then simply you can ask with me. Then I also try to give the solution for after completing the 3 hours live training program. Okay, so let's go start. So let me share my screen. Yes. Okay, can you see my screen? Is it visible? Okay, can you see my screen?
Yes, sir.
Okay, thank you. So let's go start. So basically today's session I try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat or Sentinel. So this type of satellite imagery, how we can easily filtering and displaying, as well as how we can easily create the different types of satellite composite. We also discuss about that band combination, how we can easily apply the different types of band combination, and finally how we can easily export the satellite imagery. So we can easily export the satellite imagery from Google Earth Engine, Landsat, Sentinel, Modis, or any other satellite imagery. We can easily export from that Google Earth Engine, as well as any kinds of data, how we can easily import, filter, then reduce, clip, and display any raster data in Google Earth Engine. We also discuss about that. We also discuss about the time series chart, how we can easily create for any data set, mainly any ready-made data set. Actually, Google Earth Engine data catalog provide you a lot of ready-made data set. So this type of ready-made data set, how we can easily use and make the time series chart for temporal analysis. And also discuss about that export any shapefile. We can easily digitize our area and we can easily export our shapefile, or annual image composite. We also discuss about that, basically annually or monthly image composite. So this type of temporal, yearly or monthly, how we can easily make, we also discuss about that. So let me open my slide. So we already know about that Google Earth Engine is a vast data catalog. In this data catalog, we can easily find out lot of remotely sensed data. And when we are using this type of publicly available data catalog, we don't need to download any kinds of satellite imagery, because all of satellite imagery we can easily access from Cloudly. Basically Landsat, Sentinel, Modis, Train, land cover, atmospheric. So different types of raw imagery, top of atmospheric reflectance, surface reflectance. For the Modis, different types of temporal, daily, monthly. Okay, different types of data, different types of train data such as SRTM data. Also we can easily find out that all of uh, SRTM data we can easily find out, as well as we also find out the different types of ready-made land use land cover data, different types of atmospheric data. Okay, and this data set is daily updating. So we can easily find out that update dataset from this Earth Engine public data catalog, and this is the main link about that. So you can simply visit the link, then you can easily access all of dataset. Or if you want, you can simply visit the code editor. From the code editor, just browse data catalog, then you also access this link. And this is our Earth Engine data catalog page. So in this page you can see different types of surface temperature, climate data, atmospheric data, weather data, different types of imagery, Landsat, Sentinel, MODIS, high resolution imagery for a specific region, such as NAIF. It's very high resolution imagery, freely we can get, and this data series is only available for United States. As well as also different types of terrain data, land cover data, or cropland data. Okay, so different types of data we can easily find out from Earth Engine public data catalog. And click on the Landsat, so then we can easily find out all of Landsat image collection for different time phase. Landsat 9 available between this time, Landsat 8 available between this time, Landsat 7 available between this time, Landsat 5, Landsat 4, Landsat 1 to 5. All of image collection is available for the Landsat. Clicking on the Sentinel, then we got all of Sentinel image collection, such as SAR data, Sentinel 1 SAR data, or Sentinel 2 multispectral instrument. Okay, as well as also we can get the ocean color Sentinel 3, or Tropomi for Sentinel 5P. So this type of data we can easily find out from here. And also click on the MODIS, then we can easily get all of MODIS product, such as daily MODIS product. It's one kind of trap vegetation, continuous fields, yearly global 250 meter resolution, this data set. So this is the daily product. So different types of product we can easily find out from the MODIS. Also you can see the different types of data. This is the aerosol optical depth data. Okay, so this type of data you also try to further study, then you can easily get which data provide you which information. So you can see there's a lot of data is available. Right, for the different purpose we have to use the different types of data, and we can easily get, and this type of data called as a ready-made data. Okay, you can see this is the leaf area index. Okay, aqua leaf area index. When you monitor, then we have to use it. Also you can see aqua gross primary productivity, aqua net primary production. This is the aqua land surface temperature. Okay, aqua land surface temperature. So different types of data we can easily find out. You can see the mode is combined 60-day temporal, usually temporal 16-day. Okay, NDWI. So there's a lot of data sets are available in Google Earth Engine publicly available data. We can easily find out from here. So now I try to discuss about that how we can easily filtering the image collection. We already know about that image collection is one kind of data type in Earth Engine. So mainly Earth Engine based on total 5 data types. From the 5s, one data type called as the image collection. Image collection mainly set of images. Okay, so now I try to discuss about that how we can easily filtering the image collection, and discuss about the practical example also. So let me open my slide. So when you filter your image collection, suppose you have more than 1000 images. So now this image 1000 images you just filter. So how I can filter this image collection? So this filtering process is the depend on some factor. So one factor it's called the region of interest. Suppose which area or which boundary you need the satellite images. This is the one kind of factor for filtering. Suppose I need the satellite image for Dhaka city boundary. So this Dhaka city boundary or this study area is one kind of factor for filtering. Second factor is image metadata. Suppose I need only for those image which image will be not more than 1% cloud cover. So this is the another factor for filtering image metadata. I need only for those image which image will be not more than 5% cloud cover, 10% cloud cover. Okay, so this is the another factor for filtering. And third factor for a specific time period. Suppose I need the image in year of 2017. I need the image in year of 2017 month of January. I need the image suppose year of 2017 summer season, rainy season, winter season, or any specific time period. You always remember that when you filter your image collection, this filtering process is depend on the three factors. First factor, your region of interest. where you need the image. Suppose in this case, I need the image for Dhaka city. Second factor, image metadata or image properties. Suppose I need the image, this image cannot be more than 1% cloud cover. So this is another factor for filtering. Third factor, a specific time period. Only year of 2020 or 2020 month of January or 2017 summer season, rainy season, or any specific time period. So using these three factor, you can easily filtering Landsat and Sentinel. Not only for the Landsat, Sentinel, any image collection in Google Earth Engine, any image collection you can easily filter using this three factor. So let's check the practical example. Okay, so here I already opened my code editor. In this case, I want to show you one example using Landsat. But after that, you also try for other image collection. You can see Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All of image collection, when you filtering, just apply the same process. Okay, so if I just show you for Landsat 8, this same approach you can also apply for Landsat 9 or Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All of are the same process. But this is the version. Basically, you can see Landsat 9 is available between this time, Landsat 8 is available between this time, Landsat A7 is available this time, Landsat 4 available this time. So different time we find out the different Landsat collection. So in this case, suppose I want to show you for Landsat 8, but you also try for Landsat 9, Landsat 7, Landsat 5, Landsat 1 to 5, all of others you also try. So let's go, Landsat 8. So now we find out here, you can see Landsat 8, not only for the Landsat 8, all of image, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, all of image collection, we find out these three types of reflectance. One is the raw image. Okay, raw image, basically this raw image is not calibrated any kinds of correction. Okay, but if you check the surface reflectance, this image is already atmospherically corrected for surface reflectance, it already. So in this case, if you are using the surface reflectance, you don't need to apply any kinds of atmospheric correction, you don't need. If you already work with ArcMap or QGIS software, you download the satellite image from other sources, mainly Earth Explorer or USGS website. Then further we need atmospheric correction. We also need different types of enhancement we need for getting the more better imagery. But in this case, in Google Earth Engine, when you apply this image collection, surface reflectance or top of atmosphere reflectance, then we don't need to put any kinds of correction. We don't need. This image is already atmospherically corrected reflectance, surface reflectance and top of atmospheric reflectance. So both are the same process when you filter. So in this case, I try to show you for the top of atmosphere, and both are this image, satellite image, you have to use for the different purpose. Suppose when you are using the land use, land cover classification or land surface temperature monitoring, then we have to use the surface reflectance. Suppose you want to monitor different types of vegetation index, NDVI, EVI, or water index, NDWI, or SAVI, then you can easily use the top of atmosphere. Okay, so let's go. I try to show you for the top of atmosphere. Further, you also try to discuss about the surface reflectance. When I talk about the land use, land cover classification, then you also get the more better idea. But filtering process are the same, both of image reflectance. So just take a click on the top of atmosphere. So now I got all of information about this image collection. Okay, so now this is the collection 2. Previous it was collection 1. Okay, so now previous you can see it show the collection 2. Okay, because it's the collection 2, it's the new update version, but previous time it was collection 1. Okay, so this collection 2, this is the version tier 1 and top of atmospheric reflectance, TOA. Okay, and this is the Landsat, this is the LC08, mainly Landsat 8 collection 2. This is the tier 1 top of atmosphere reflectance. So this is the ID about this. Every image collection, not only for that, every image collection, it can be Landsat, Sentinel, MODIS, or any data set, we find out this type of unique ID, mainly snippet ID. It also called the unique ID. So this unique ID further we can also use in the Python. You can simply copy this unique ID. Suppose I need the data. So this full data is stored in this path. So this is one kind of directory. Suppose when I go to this directory, Landsat LC08 C02 tier 1 top atmosphere, this is the directory. When I go to this directory, I can easily find out the Landsat 8 image collection. And this image collection is available between this time 2013 to 2024, this time 1208. So this is my availability time, and this time is also updating, and it will be start from here. And dataset provider mainly USGS and Google. This is the dataset provider, and you can get all of information about this dataset. Okay, as well as you can get all of bands. So here you can see we find out the B1, B2, B3, coastal aerosol, blue, green, red, near infrared, short wave infrared 1, short wave infrared 2, panchromatic band B8. So all of bands, QA pixel band. Basically this band help you to remove the cloud. So further I also discuss about this type of work, QA pixel band. So now this is my image collection. So this image collection I want to filter for my specific boundary, for a specific time period, for a specific filtering a specific metadata. Okay, so let's go. So first of all, this image collection I need to import in my code editor. Okay, so this is my code editor, and this is my dataset or image collection. So this image collection you need to import in the code editor. So how I can import? So one way is that you can simply copy this ID, copy this snippet ID, just copy and paste on your code editor. Just I increase it and then paste here. Okay, so now this is my image collection, and this image collection mainly for Landsat 8 collection 2 tier 1 top of atmosphere reflectance, and this is the directory. So this image collection just store it in a variable. Previous class I already discussed about that, how we can define the variable. Apply the same process. Just before the variable name, just put the var keyword, and put the variable name. You can put almost any name we can apply in here, any name we can apply. Suppose I just put the name L8 and then equal sign. So now this is my image collection, and this image collection I just store it in a variable. This variable name is the L8. So now this L8, this variable stored the full image collection. Okay, full image collection is stored in this variable. And we already know image collection is one kind of data type in Earth Engine, mainly set of images. So if you simply search here, suppose go to the docs tab and search here, suppose image collection, I simply search and find out the image collection function. Yeah, this one. Yep. So you can see image collection. So this is one kind of function in this is the main function, image collection. In this main function we also find out some sub function, image collection. In this case we are use it. Okay, this function I just use in here, e.image collection, and then put here this directory. Okay, construct from the following argument. Okay, so just we put here this is our directory, and this is our image collection. This is the function of image collection. Suppose when you define any kinds of image collection, then we have to use this image collection, and further we simply put our directory, and this directory come from our Earth Engine public data catalog from here. Okay, so now in this image collection I want to filter. Okay, if you check some function, simply go to the below. So in this time, in this image collection, I want to check how much images are available. It's an image collection, but I want to check how much image available in this collection. So for that we have to use a function. Okay, first of all this function, size function. Mainly if you click on here, you can see this size function return the number of element in a collection. Okay, suppose when I just use the size function, this size function help you to count the image in this image collection. In this image collection, how much images are available if you want to count, not only for that, any image collection. Suppose you have a image collection for the modis, suppose modis ndvi. So now you want to count how much images, and it's very important when you make the time series chart. So before making the time series chart, you must need to check how much images are available in your collection. Okay, and this is the function always we are use size function, return the number of element in the collection. In this case, this is my collection, image collection. So I want to count how much images available in this collection. So that's why I need to use the function size, and this function integer return the integer value, mainly number. We find out the number. So let's go try to apply this size function and then check what happened. So let's go. So just I print this collection. I want to print this L8 because L8 is stored the full image collection. Okay, L8 is stored the full image collection. So now I want to count how much images available in this collection. I need to use this size function. Just put here the dot size. So now if I run the code, it's computing how much images are available in this collection. Just run the code. And what is the time period? Time period, this time period from 2013 to 2024, how much images are available in this collection, it computing. So now it's count how much images are available in this collection. Okay, counting because there's a lot of images, and we can see. Okay, let's see. So more than 1 million images we can easily find out in this collection. Okay, this is the total image collection for Landsat 8 for the whole world between this time period 2013 to 2024. Between this time period we find out this large number of image collection. Okay, so now this image collection I need to filter. And how I can filter? For filtering, we already discussed the three factor. First factor is region of interest. Second factor is image metadata or image properties. Third factor for image specific time period. So let's go try to use it, this three factor, and filtering our image collection one by one. So let's go. So in this case, this is the full image collection. We find out this large number of image collection for the whole world between this time period 2013 to 2024, this time period. So now this image collection is available for the whole world, but I don't need for the whole world. I need for a specific boundary. If you want, you can also take the marker, or if you want, you can also take this type of boundary. There is no problem. If you want, you can take this marker. Also, there is no problem. In this case, I want to apply my shapefile. Suppose I already import a shapefile. So this boundary, I need this satellite images. So I define it. So go to the asset tab, and previous class I already discussed about that how we can easily import the shapefile. So here I already imported the shapefile. Suppose you can see this is the Bangladesh district boundary shapefile. Here available all of district in Bangladesh, or any shapefile you can easily import and also work with that. So this is the shapefile, and this shapefile you can see all of are available, all of districts are available. Suppose from this I just filter the specific district, and then I try to show you that how we can easily get it. Okay, and it's stored the name too. Okay, just import. So now this table, this variable stored the full total 64 district in Bangladesh. And previous class I already discussed how we can easily filter. Just apply the same process for filtering to get the boundary. Just take a variable, suppose RY, and then I call the table. This table I set a filter. Then how I can filter? I want to filter earth engine dot filter dot equal So now it's arise a question, what's equal what, mainly name to equal, I put the value, suppose Dhaka. So now from this table, from this collection, from this table, basically it's the total 64 district, just a filter. How I can filter? Where name to equal Dhaka. So now this Dhaka boundary is stored in the ROI. ROI is stored at the Dhaka boundary. Okay. So now if you want to check the boundary also, we already know how we can easily add the layer. Just use air map dot add layer and add the boundary. Suppose ROI. Just put here ROI. And also focus on the given study area. Map dot center object. These two functions you already know. Just I put here ROI. Zoom level 10 and click on. So now we can easily find out our study area. So this is my study area. I need this satellite image for this study area or for this boundary. Okay, but we already computing the large number of image collection for the whole world, but I don't need for the whole world. I need only for the specific region of interest. Suppose this is my study area. So now we need to use a function for filtering the study area. So we simply go to the docs tab again. In this case, we need to use this function called the filter bounds function. In this time, I just filtering the boundary. Suppose I need the image only which images are available only for this boundary. Other place image I don't need, or other region image I don't need. So let's go try to filtering. So further we need to use the filter bounds function. You can see this function, filter bounds function. Okay, so if I just on the click on here, you can see this shortcut to filter a collection by intersection with a geometry. Geometry mainly your point line polygon. In this case it's a polygon or boundary. So now we have to use this function, filter bounds function, to filter a collection by intersection with geometry. So we already know this is my large number of image collection. So this image collection I just need to filter by intersection with my study area. So that's why I need to use the filter bounds function. So let's go try to apply it for filter region. Just take a variable. I put the variable name, suppose filter region. You can put any name as a variable. So now this is my image collection. This image collection I need to intersection with my geometry. So this image collection is stored in a variable. This variable name is L8. Okay, because you can see when I apply the L8 and use the size function, then we find out this image collection. So this image collection is stored in this variable L8. Just I copy this image collection. I need to filter for intersection with my study area. So for that I need to use the function filter bounds function. And if you check what is the argument is the geometry. Geometry mainly point line polygon. In this case this is my polygon, and this polygon Dhaka city boundary, this polygon is stored in a variable. Just write the variable name in here. This variable name is the ROI. Just copy and paste here. Okay, now further I want to check how much images are available in my boundary. Okay, in my boundary how much images are available only for this boundary. Just print again and call the filter region. Just copy and paste here and use here the size function for computing or counting the number of images. Just run it. So now it computing how much images are available only for this study area. We find out 664 images are available only for this study area, which I use in here, only for this polygon or boundary. Okay, but previous time for the whole world we find out the large number of image collection, but when I filter for a specific boundary with intersection with the specific point line or polygon, in this case I just use here the polygon. So that's we find out only for the 664 images are available. Okay, so in this case I filter using my study area or ROI. Now we talk about the another. Suppose from 664 images I just need only for those images which image will be not more than 1% cloud cover. In this case I just filter image properties. I don't need all of images. I just need only for this image whose image will be not more than 1% cloud cover or 10% cloud cover, 5% cloud cover. Okay, so then how I can filter the image properties or image metadata? So for that we have to use this function filter metadata. So if I just run the code, you can see, so now it also deprecated. Use filter equal or greater than is also available. Deprecated means that now this function is not more useful. Okay, so we just use here the filter and with e dot filter equal. Suppose I just need the result for equal 10% or greater than equal or less than, lte less than equal or lt less than. So we also use it filter metadata. Also there is no problem, it also available in this function. So now this function filter metadata function mainly help you to filtering the image properties. Image properties means that from 664 it's a collection, 664 it's also a collection. From this collection I just need only for this image which image will be not more than 1% cloud cover. So just I use this function filter metadata and then we can easily filter image metadata, a specific cloud cover level. So let's check. So for that, just you can take a variable, suppose filter metadata, and this type of variable you can put any name. Okay, it's not mandatory to use the same name. Variable can be anything we can write. Then equal sign. So in this case, from 664 images, I just need only for this image which image will be not more than 1% cloud cover. So now what's variable stored this image collection? Anyone can tell me what is the variable stored this image collection? What's the variable name in my code?
Filter region, sir.
Yes, filter region. Because you can see when I just call the filter region and then use the size function, then it computing 664 images. So this 664 images is stored in this variable. Okay, so now from 664 images I just need only for this image which image will be not more than 1% cloud covered. So that's why I just call this variable, just copy and paste here. Okay, then use this function filter metadata, just put here filter metadata. And now if you check what is the argument for this function, just click, you can see first argument is the name, then operator, then value. So now what is the name? If you check the name, you can see the argument name mainly it's a string data type, and the name of the property name, property to filter. So now here I find out the property name. So always you find out this property name in the dataset information. You can see the image properties. So here you find out the lot of image properties. You can see there are a lot of image properties for the different purpose. We are using the different types of properties. So in this case I just use only for the cloud cover. Suppose I just filter using the cloud cover. Just I copy this property name, and this property name is a string. You can see it also mentioned in here, it's a string. And you already know when you print any string we must use here the quotation start and end. So you also must use in here quotation. Just put here the quotation and put the property name cloud cover. Then check the second argument is the operator. What is the operator? If you check it, operator is also a string. So operator can be equal, less than, greater than, not equal, not less than, not greater than, starts with. So I want to use here suppose less than. Simply copy less than, and it's a string. You must use here the quotation and then put the value. So in this case what happened? In this case this variable filter metadata variable is stored only for those image which image is less than 1% cloud cover. Okay, so let me try to check it how much images are less than 1% cloud cover in my study area. So for that same process, just call the print and call this variable name filter metadata and use at the size function and run the code. So now it computing in my study area how much images are available less than 1% cloud cover. We find out that 119 images are available, and this 119 image is less than 1% cloud cover. Sometime you get the zero or null, there is no image. Suppose mainly when you work with coastal area or river bank or any place where always cloud formation, so you just try to check less than 1%, you try to check the less than 1%, then it show the zero. Zero means that there is no image less than 1% cloud cover. Then you have to increase the value, check 5% is available or not, 10% is available or not, or 20% is available or not. You have to check it. So first of all, we always try to take the low cloud cover imagery always. So for that, if in my region, I can easily find out when I put the less than 1%, I can easily find out that 119 images are available for my study area in Dhaka city. But when you work with riverbank or coastal area or any other place where always cloud formation, then you get the zero or null value zero. Then you just increase the cloud cover level. Suppose in this case, if I just increase the 10%, you can see this number is also increased. So just run the code, you can see what happened. 225. Okay, so for my study area, 225 images are available, and this 225 images is less than 10% cloud cover. Okay, so in this case we try to keep 1%. Further we also discuss about that how we can remove the cloud. Then I also try to show you that for the coastal area or river bank, this type of place, practically how we can easily remove the cloud and get the very neat and clean satellite imagery. Okay, so now we find out that total 119 images, and what is the time duration. This time duration, in this case you can see we are not filtering the date, we are not filtered any kinds of date. So that's why which date default in here between this time 2013 to 2024, we find out that 119 images, and this 119 images is less than 1% cloud cover. Okay, but I don't need for the whole time period, I need for a specific month, a specific year, or a specific season, or any specific time period. So for that we have to use this function filter date. So you can see in this case this is my collection. So from this collection I just need to filter a specific date range. Suppose I need the image year of 2020 or 21 or 20 summer season or rainy season or any other specific time, when just you can put the time period. So let's go and let's go try to apply. So just I take a variable, suppose filter date, you can put any name as a variable, there is no problem. So now I just apply here. So can you tell me what's the variable stored the 119 images? What's the variable name? Anyone, please?
Filter metadata, sir.
Yes, filter metadata. So just copy the filter metadata because I want to filter this collection from 119 images. I need only for those images which images are available in year of 2020. Okay, so just I call the filter metadata, just copy and paste here, and then apply the function filter date function. Okay, and if you check what is the argument, this argument is the start and end. So what is the start? If you check, start mainly start date, okay, number we can put in here, also string, it's a you can date number or string we can include in here, also you can say int number or string. So let's go try to add the start date and end date, and this is the number and string. So we have to use the quotation also, just I put here the quotation, you can see, just put the quotation, suppose year of 2020 1st January from year of 2020 December 31. Okay, so just a quotation, also put this date, start date and end date. So now I want to check for my study area between this time period 2020 1st January to December, how much images are available. So let's go, just print, same process, print and call the filter date, and then use at the size function. and now run the code. So now it computing how much images are available. We find out that in year of 2020, 12 images are available between this time. Okay, and this 12 image is available in my study area, as well as this 12 image is less than 1% cloud cover. So this is the filtering process. In this case, you can see I just first filter for my study area where you need the image. Then second factor is that image metadata or image properties. I need the image less than 1% cloud cover. And finally, specific time. I need the image, suppose this is this time, year of 2020, January, December. So we find out that 12 images. Okay, so now anyone in question about that any function, you can ask me. I will try to again explain for the filter bounds, filter metadata, and filter date. So we try to use the three new function: filter bounds, filter metadata, and filter date.
I think I just missed. Can you explain why we need the shapefile? Uh, shouldn't we can do it from the image collection?
Yes, okay, understand. Yeah. So basically, in this case, when you filtering the image collection, this filtering image collection, basically this image collection is for globally. Okay, this image collection is available for the globally. But when you filter this image collection, this filtering process is defined on three factors. I can filter using my specific boundary. Suppose I need the image for Dhaka city. So that's why in the Dhaka city, if you want, you can take a polygon, or you can take the marker, or just simply select your study area. Where you need the image. So for defining this thing, we simply import our shapefile. If you want, you can also take suppose you can also take this rectangle, also take the point or marker. Basically, it defined the geometry, or it's defined the polygon. Which polygon you need this type of images. So that's why we simply import our study area. Suppose I need the image for Dhaka city boundary. So just I simply call the ROI and stored this variable my study area. And filter bounds function. So this first image collection, for the whole world. But I don't need for the whole world. I need only for those images which images are available in my study area. So that's why I simply import my study area Dhaka city boundary and use the filter bounds function. And this function helped me to filter a collection intersection with my geometry. In this case, ROI is my geometry for Dhaka city, Dhaka district boundary shapefile. We find out. Or not only for that, if you want, you also take this polygon or marker and also use it as a geometry also. There is no problem. Yes, any question, please? Okay, I hope there is no question. So now in this case, I find out the final output 12. Okay, 12 image collection. And this 12 image is not captured at the same time of the year of 2020. Year of 2020, different time this 12 image is the capture. So now I want to check all of information, mainly image acquisition time, all of things I want to check for this 12 images. Okay, because this 12 image is not captured at the same time or same date in year of 2020. So different date it captured the different images. So I want to check all of information for acquisition time, all of details of properties for this single images. So let's go try to check it. So for checking these things, just print this filter date, because this 12 image is stored in the filter date variable. Just type paste and click to run. So now you find out all of information about total 12 images. So you can see, let me just decrease. So you find out the 12 images. Okay, just click on here. You can see type is the image collection. In this image collection, total 12 images are available. Just click on here. You can see we find out 0 to 11, mainly 12 images in here. And if you just click on here, you can get the type. Type is the image. Okay, so all you know about that, image collection is one kind of Earth Engine data type. Also image is another data type. Okay, image mainly just a single image. It's a single image, not group of set of images. Set of images, basically this 12 So that's why it show the image collection. But when I open the single image, it show the type, as the image. Okay, and you can see here in this image collection, we find out this image, this is the acquisition time, 2020 11th February. Or if you just click on the properties, then you can get all of information about this single image. Click on here, you can see that this is the cloud cover. Okay, this is the tier 1, collection number 2, this is the data acquisition time. So all of details we can get for this, all of properties we can get for this imagery, and this is the single image or single tiles. So now I want to visualize this single tiles. Suppose I just only visualize this image, which image acquisition time, this time I want to visualize it. So for that, how I can visualize? So just for doing these things, we need the type of image. Okay, so if I just click on docs tab and find out the function ee.image, so you can see image, image. Just click on here, you can see I simply search here ee.image and find out this function. Why is it? Yeah, ee.image. Here you can see. So when you visualize, when you stored any single image, not collection, when you stored the collection, you already know we have to use this function ee.image collection, but and then put the directory. Okay, but in this case I want to visualize only for this single image. You can see this function ee.image, and then we define the id. Okay, you can see string and earth engine asset id. So in this case I want to visualize the single date images, so that's why I just need to use this function, and in here I just input my id of this image. So just I copy this single image because it's just a single image visualization I want to visualize. So for that, just paste this function, and I want to visualize this single image. You can see this is the single image. Just copy this id, just paste, copy, and then it's a string, just use it and paste here. Okay, so now these things I want to store it in a variable. You can put any name as a variable. I put the variable name, suppose image. Okay, so now ee.image, basically this function help you to visualize a single image, not image collection. And then I put here the image id. You can see all of images have an individual id. All of images have individual id, okay, all of images individual id. So you can simply use it and further we check what happened. So now if you check, suppose I just print, I want to check the information only for this image. So now run the code. So now we got all of information about only for the single images. So you can see it show this type of information, and this is the single image. You can see it show the image, but previous one show as the image collection. So it's an image. This image contains total 17 bands, and you can get all of details information about this image. So now this image I want to visualize in my map. So let's go try to visualize it. So just use here map dot add layer and call this image and run it.
Can you explain what is a band?
Okay, so basically bands, it's very basic things about the remote sensing. So in remote sensing, where you had the different types of bands, stored the different types of radio electromagnetic value stored in here. Suppose coastal aerosol or red, green, near infrared. So if you check this type of band, so basically we find out the information. Okay, suppose it stored the spectrum value. Spectrum value means that pixel value. Okay, suppose coastal aerosol, blue, green, red, near infrared. So this type of value is stored. Basically active remote sensing, passive remote sensing, this type of things stored this type of information. Okay, basically wavelength value. Okay, and this wavelength value generated from electromagnetic radiation in the satellite or sensor stored, and from this sensor we find out this type of value, and we are just use this type of band, and further we can also use the different types of information from the satellite imagery. Suppose we are using here the different types of band combination. Band combination I also discuss further after some time. So using this type of band, we are using here the different types of band combination, and then we also try to easily find out the different types of feature. Okay, suppose I can use the true color band combination, false color band combination, or I also show you some sources also about that. You also try to read this article. I hope you can easily get the idea how we can easily create the band combination or other things. Okay, so let's try to explore one by one this thing. So now we find out this type of images. You can see it added the image, but this image have a one problem. It's not fully fill up my study area. Okay, basically it's a common problem when you want to work with the big study area. Then we face this type of problem. One image or one tiles or one scene is not capable to fill up your whole study area. So you can see here in this case, when I just use this imagery for this time, this image acquisition time, this time when I used, it's just fill up only for this part, but some part are missing. So there is the another solution. Further also discuss about that. For this solution, we are just use here the composite. Then suppose I need the image for the whole country boundary of Bangladesh, and whole country boundary of Bangladesh, one tiles or two tiles is not fully fill up the whole country boundary of Bangladesh. So that's why for this time we also need to use here the composite. We can use here the median composite or mosaic composite or mean composite. So now suppose you also check, suppose one tiles is not fully fill up my study area, then you try to check the other images, what happened about that. Suppose just I click on here and just click on here, I want to check suppose other imagery. Suppose I want to check suppose this imagery and then check what happened. Just copy these tiles and then change the ID and paste. Now run the code. So now let's check what happened for these tiles. Is it fully fill up or not? Okay, I think okay, it also, yeah, it also fully fill up, almost fill up, you can see, but some place is not fully fill up also. It's some very not much, little. Okay, so I think for the Dhaka city boundary or a small study area is possible to fully fill up. Okay, so when you work one by one, you try to check which tiles is fully fill up your study area. So in this case I not get check all of image. So but when you work for your own study area, you try to check. Suppose you need the singularity image, you are not create any kinds of composite, so you can just simply check which tiles is fully fill up your study area properly. Suppose in this case this image is fully fill up my study area properly, so I want to use these tiles, and this tiles acquisition is that year of 2020 27 December. So when I click,
So
please
I have one question.
please.
If our study area is not fully covered in that tile, so there is any available option for
Yes,
merging of that tiles?
yeah. So for that we have used the composite. Composite, we just call all of images and create the composite, then it fully fill up for the whole any big study area. Suppose you need the satellite image for the whole country boundary of Bangladesh or India, then one tiles or two tiles is not fully fill up. So that's why we have to use the composite, as well as you just simply select some specific tiles and then also make the composite. So I'll share that further later. I'll try to discuss about that. Suppose now I got my images look like that. So it's an image. Okay, so now this image I just need only for this study area. Okay, you can see it also shows some other place also, but this type of place I don't need. I just need only for my study area, so that's why we are just use a function. And if you check the function, I will show you also from here. Suppose I simply go to this e.image here, you can see, where is it, image. So now it's a image, this data type is the image. So image data type, all of function, you can see different function, all of function we can applicable for the image. Okay, suppose ee.image collection, you can get the title or heading is ee.image collection, then all of function you can only applicable for that image collection. So it's very important thing is that suppose some function is only work for image, some function is only work for image collection. So here you can see ee.image, this is the title or heading. When I click on, I can get the all of sub function. So all of function only work for image, not image collection. Suppose I show one example. Suppose you can see where is it, yeah, clip. So clip is one kind of function. This function you can only applicable for image, not image collection. Okay, suppose in this case it's my image, I can easily apply the clip, but when I try to clip in my image collection, then it show a problem. So I will show you that. Suppose in this case I just try to use the clip function in here. It's a image collection, we already know. More than one image means that image collection. Suppose I have a two image, so it also called as image collection. So in this case, if I just apply here that dot clip function, you can see what happened. Clip with study area, suppose ROI. If I run the code, it show a problem. You can see it show a problem. And what is the problem? It show that you can see clip is not a function. Okay, clip is only work for image. That's why you can see here ee.image, it's my heading or it's my data type. So all of function under the image is only work for image, not image collection. Let's take another example. Suppose I just remove it, and suppose size is another function. Okay, so if you check where is the size function, let me check it. We find out the size function only for the image collection. So if you check it, where is the size, you can see size, where is the size? So all of function you can only applicable for the image collection. You can see all of function size. So size is available for the image collection heading. You can see this heading is that image collection, image collection, image collection. So now this size is only work for image collection. If we want to use this function in the image, it not work. You can see this function is only work for the image collection. Suppose if I just use here the size function, you can see what happened. Just I put the size function and then run it. We find a problem. This problem is that you can see the size is not a function, because size is only work for the collection, image collection. But in this case it's my image, it's not the collection. So that's why size is not work here. But when I work with collection, mainly more than two images, then size is work very well. So it's very important, you always try find this type of problem. So that's why you check the heading and then also check the subheading. So in this case size is available, you can see size, this function is available only for image collection. So that's why I can easily apply this size function only for the image collection. But when I apply this function in the image, it show a problem, size is not a function. Okay, so I hope we can got the idea how it will work. Okay, so now this size is not working here, but we can easily apply the clip function, because clip is work only for the image. So just I use here ROI and run the code. So now it just clip with my study area. You can see we find out this type of imagery. Okay, but this image look like as this type of color, because you can see if you check the map.add layer after the image, what the second argument? Second argument is the image visualization parameter. If you check again the layer function, you can see the function map.add layer. So after object, in this time image is my object, then you have to define the visualization parameter. In the second argument we have to add it. In this case I don't add any kinds of visualization parameter, that's why it look like that. So now how I can add the visualization? In this case, in the satellite imagery, we just use here the different types of band combination. So now what is the band combination? Band combination is the combination of three band. Okay, basically three band create the one combination, and we are using the different types of band combination to identify different types of feature from satellite images, as well as we are also using the band ratio, and it's very useful for mineral exploration. We also use the different types of band ratio, and we can easily locate the different types of mineral. So in this case, band combination, only for the three band we can create the one combination. So now how I can create the band combination? So for creating the band combination, you can see this layer stored the image. Just I click on here, you can see B1, B2 and B3, and also grains, this type of things. So just I create the band combination. Okay, so when I select the first band is the red, B4 mainly red. You can also check the description about the band. B4 is the red. When I select the red, then put at the green and set the blue. It's called the RGB, mainly red, green and blue. Naturally human I can see. Okay, suppose vegetation show as a green color. Naturally when you fly on the aeroplane, naturally which type of things we can get, the same process also in here. So just I put at the red, green and blue. When I apply, then I can get the natural color combination. And after that you can see it show the range mainly. In this case we need to stressing. Stressing is one kind of data visualization process. Suppose you can see different types of stressing level in here. Okay, so stressing is one kind of data visualization process. So if I click 98%, you can see it automatically show the mean and max range. So when I just put the 98%, it automatically show the mean and max range, and between this range it show me the visualization. When I put here suppose 90%, it automatically change the range, and between using this range it show me the visualization. So stressing is one kind of data visualization process or method. These things we can use different map. For the different map we need to use the different types of stressing level. Suppose, and this 98%, this level is the middle, and stressing 100% is very high level, and 98% is the middle level, 90% is low. So I will always try to keep 98% stressing. Okay, so it's just a visualization process. For your data automatically set the mean and max value, or range set the mean and max, and using this range show you the visualization. Suppose I put the 98%. Okay, also you can see the gamma value is very important when you want to, suppose you get the imagery very suppose dark. Okay, not, and also get some hair. So I also discuss further later how we can easily work with gamma also. So just I try to apply and just check what happened. So you find out this type of imagery, you can see. Just I zoom. So this is one kind of satellite imagery, Landsat 8 for our study area. And this acquisition time, this is the acquisition time. And in this case, I just apply the red, green and blue, this band combination. Then I can get the naturally. Naturally, we can get this type of visualization. We can find out vegetation show as a green color. Also, we can find out this type of building. Okay, building, this is the building. We also find out this type of green color. Okay, green color mainly vegetation. Also you find out this type of things, you can see this is the cropland. Okay, also you can find out this type of things is the vegetation or trees. This type of things the vegetation trees. We find out it's a river or water body. Also you can get the lake. Also this is the water body. Also this is the water body. Okay, we also find out this type of, you can see it's a construction or build up. Also you find out this type of vegetation. Okay, also you can see it's a build up or settlement, or naturally you can find out this type of things. So it's one kind of band combination. When I set the band combination, So now this visualization parameter I need to import in my code editor. Okay, so when I just click on the import, a new line of code added in my variable. Okay, when I click on the import, it added. Just copy this variable name and paste after the object name, because always after the object name we put here the visualization parameter. In this case, this variable stored the visualization parameter. Further, we set the name mainly layer name. I put the layer name, suppose it's a true color. Run the code. So now this visualization is set it with my code. You can see find out this type of visualization. Not only for that, we also use the different types of band combination. Another example, just click on here again. You can see it's a true color because I put the name true color. Just click on here. Suppose I want to use another band combination. It called the near infrared, then red and blue. Okay, suppose stressing 98% I keep, and then just click on the apply. So it show me the another band combination, and it's also very helpful to identify for vegetation. In this time, this type of red color indicating about the vegetation. Water body show as a black color or dark color. Okay, we can easily find out this type of things. Just I also use this visualization in my map. So just click on the import again. You can see when I just click on the import, and a new line of code also added. So now these things I also set as a layer. So for that, just copy the same code, and paste here, and just I put here this variable name. Basically this is the another variable name, and also put the layer name. Suppose I put the layer name false color. Just run the code. So now you can get the two layer. You can see one layer display the true color, another layer display about that false color band combination. Okay, vegetation show as a red color, and better vegetation it also shows the more red color. Okay, if you zoom, then you also get the more better. Okay, this type of red color indicating about the vegetation. It's a vegetation. It's a water body. And you can see this type of gray color indicating about the barren land or fallow land, this type of things. Okay, barren land. And this type of, you can see it's a vegetation. So it's very important because when you taking the training sample, applying the machine learning
Sir,
in
I
Google
have a
Earth Engine,
question.
we also try to use this type of things. Yes, please. Yeah, please, any question, please.
Sir, sometimes village boundary is too small. So, what kind of satellite image I have to collect from satellite census data?
Okay, so
Here you collect
yeah.
Lancet 8. When I using village boundary such type of data and different field locations, different crop fields like paddy, like wheat, how I intercept and separate those field locations.
Okay, understand. Okay, so basically we are using the different types of commercial satellite imagery for this type of work, because freely available, only available for the Sentinel-2 satellite imagery, freely available. It also work possible to work with the Sentinel. It's the Lancet. Okay, Sentinel we also find out the more better resolution than Lancet. Okay, 10 meter, it show the 30-meter pixel size, 30-meter pixel size area for the Lancet. But when you work with the Sentinel, we find out the 10 meter, 10 into 10, mainly 100-meter square area cover, 1 pixel. So pixel mainly you can see when I zoom, you can see we find out this type of pixel. When I also more zoom, you can see we find out this type of pixel. Okay, so in the Lancet, this pixel size is 30 into 30 square meter. Okay, but when you work with Sentinel, then we find out the 10 into 10. So then we also get the more better result freely. But if you have some commercial software, then you also get the also more better result. As well as now drone image is also possible to work this type of things. We also use that the drone image, we take this data and also further analysis, also apply the machine learning, deep learning, and also try to make the segmentation other work, it also possible. But if you do for the freely, then I think Sentinel-2 is more better. Okay, it's just because Sentinel-2 is available 10 into 10 meter square area, so one pixel, this pixel size 100 meter for that sentinel imagery when you want to use, then it also get the more better accuracy also. Okay, okay, suppose I want to add the another band combination, just click on here again, and I said suppose in this case short wave infrared 1, then near infrared, and put the blue stressing 98%, and then apply. So now you can find out this type of band combination. It's very helpful to identify for the barren land. We can get this type of color as a barren land. Okay, this type of color is the barren land. We can easily find out. Also, this combination is also helpful to identify for vegetation also. We can easily identify the cropland. Okay, you can see barren land. So this I want to set. Just click on the import. It will be added the new variable. It is stored this visualization parameter in this variable. I want to add a layer. Just copy the same code and paste here, and then change the variable name. I put it, suppose I put the band combination. You can put any name as a variable. Band combination I put here. So now we try to set only for the 3 band combination, but in remote sensing we are using the different types of band combination to identify for different types of feature from satellite imagery. So if you check some sources, I also provide you. Suppose simply go to here and search here, suppose Landsat 8 band combination, simply search. So you can find out this type of information, 432 543 764 564 5753. It's a band number, band 4, band 3. Okay, as well as if you, okay, just it's very popular website for learning the GIS and remote sensing different types of practical. So this is a GIS geography website. You also read the Landsat 8 bands and band combination. You can get all of information for the Landsat 8, different types of band information, their wavelength or resolution. Okay, also you can see this blue band, green band, near infrared band, near short band, all of band information you get from here. As well as if you check the band combination, you can check the band combination. It's one kind of band combination. So when you use the band combination, it replicates close to what our human eyes can see. Healthy vegetation shows as the green, unhealthy flora is the brown, urban feature appears white and gray, water is dark blue or black. So 533, it's called the color infrared. So the band combination is also called the near infrared composite, and it uses near infrared, mainly near infrared red and green. So we find out that particularly red have the better vegetation or healthy vegetation. Dark areas are water, urban areas are white. Okay, so we can use the different types of band combination to identify. Also you can see short wave infrared 764, mainly agriculture 652. So you can easily find out this type of pixel. When you apply the 652, we find out this type of pixel, a square or rectangle. It's indicating about the agricultural land. But you can see when you can get this type of pattern, not a square or not a rectangle, we find out the randomly distributed. So it's not the cropland, it's not the agricultural land, it can be vegetation or trees. Okay, also you can see when you identify different types of geological formation, lithology feature or fault, then you have to use this band combination 762. Also bathymetry you can also use, and this band combination is also estimate the suspended sediment in the water. Then panchrometric, or further also discuss about this type of things, vegetation index, okay, or moisture index. So you also try to read it, then I hope you also get the idea how we can use the different types of band and which band combination provide you which information. We also get this idea from here. Okay, so this is the, we find out this type of things from here. So now this type of band combination also help you to get the training sample. Okay, further also discuss more details when I talk about the land use land cover classification. We easily take the training sample using this different types of band combination, because it's very helpful. You can easily identify where is the vegetation, where is the water body, where is the barren land. We can easily identify where is the cropland, where is the vegetation, we can easily get the idea. So further we are just take the training sample and then apply the machine learning, and we can easily classify the land use, land cover classification. So this is the process for the single date imagery. Okay, so now how I can create the composite mainly we are just use all of images, and it's very useful when you work for the big study area. Okay, but we can easily find out the single date imagery for that specific small study area is work very well. But when you work for the big study area, then this thing is not work. So then we have to apply the composite. So you simply search here, suppose satellite image composite. You can easily get this information from here. Is free. Create the cloud free image composite from the satellite imagery. Okay, so they are using the ArcPy, mainly they are using the ArcGIS, and they are write the ArcPy and also do it. But in this case, we are just apply this type of things using the Google Earth Engine, and further we try to create the image composite. Okay, so in this case, they are also using the median. We also use the same process also, and then try to create the composite. Okay, so let's go try to do this type of things also in Google Earth Engine and then check what happened. Okay, so in this case I want to apply the composite in my image collection. So this image collection I just need to apply the composite means that I just use all of image and create the single image. Okay, so I was in my collection final output we find out the 12 images. Okay, 12 images. Okay, this 12 images I want to use all of images and create a composite. I create the single image. So in Google Earth Engine, if I just open the image collection function, because now I want to apply these things in the collection, image collection. If you check all of function in the image collection subheading, all of function is only work for the image collection. In this case, I want to convert the image collection into image, so that's why I need to use the function from the image collection, because 12 it's my image collection. So now if you check some image collection, you can see this function. You can see we use here the max, mean, median, and basically median is very popular composite, as well as also mosaic or mode or mean. So basically in Google Earth Engine, when you apply the median, then it provide you the noise free images. Noise pixel automatically remove when I take the median. Mosaic is also helpful. Okay, so now what is the median? So if I just click, you can get the result. So median, it's one kind of, it's reduce an image collection. Suppose I have total 12 images, so I want to reduce this image collection by calculating the median of all values at each pixel across the stack of all meshing band. Okay, and bands are meshed by name. Okay, so this is the median mainly calculating the median value of all values at each pixel across the stack of all meshing bands. Meshing bands, how it mesh? Suppose all of near infrared band, all of red band, all of images, green band, all of images, blue band. Okay, mesh and calculating by the middle of all values at each pixel. Okay, so all of missing band by their name, and take the calculate the middle pixel value and create the single image. So let's go how I can apply the median. So in this case, if you check my single image, you can see here this place is not completed properly because this tiles is not fully fill up my study properly. But when I apply the median, because I take all of images middle pixel value, messing by their band, then it easily fill up and we can easily get that. And it also very helpful when you want to work for the big study area. One tiles is not fully fill up your study area, then we try to apply the median and then work with that. So let's go try to apply the median. Okay, and this median I want to apply in a image collection.